Good morning, everybody. Welcome to the session. This is a video contain some topics which include the idea about brief idea about the reference electrodes and the primary reference electrode, the famous one, the standard hydrogen electrode, its applications, its construction, cell representations, demerits, etc. Without introduction, I am moving to that. Myself, Eldos P. Jacob, Assistant Professor Chemistry, Department of Science and Humanities, Federal Institute of Science and Technology, FISAT, and Kamali. Shall we move to that? Yes. So, the first topic is reference electrodes. Do you have any idea about reference electrodes? Yeah, let us move to that. Reference electrodes are electrodes of standard electrode potential with which we can compare the potentials of other electrodes. The main application of reference electrodes to calculate, to determine the potential or electrode potential of an other electrode, and the value of that reference electrode cell potential is known for us. Okay, so it is of mainly two types. They are primary reference electrode, and the second one is secondary reference electrode. Let us first of all let us move what you mean by a primary reference electrode. Primary reference electrode having the cell potential value or the standard cell potential value is 0, which include mainly two ones. They are standard hydrogen electrode. When it abbreviates, it's known as She, or standard hydrogen electrode is also known as normal hydrogen electrode. Not, it's also not, it's another, that is normal hydrogen electrode. Let us first of all let us discuss what you mean by She. Standard hydrogen electrode, when it's abbreviated, it's She, is a primary reference electrode. Second point, hydrogen electrode is an example of gas ion electrode. Its potential value is taken as 0 at all temperature. You know what I mean by it. Hydrogen electrode is an example for gas ion electrode. I explained what I mean by gas ion electrodes, or the, we know that there are four mainly types of electrodes: the metal ion electrodes, metal spiningly soluble electrode. Third one is the famous one, gas ion electrode. Fourth one is redox electrode. Among that, hydrogen electrode is a gas ion electrode, in which a gas is bubbled through a solution which containing ions reversible to the gas. Okay, so this is the structure or the figure of standard hydrogen electrode. I will explain the structure or the parts, and it consisting of a beaker, and into that we can see there is a glass envelope or a glass tube which contain, the first one is a platinum wire, which contain a platinum wire. At the end there is a platinum foil is connected to the platinum wire, and that platinum foil, this is platinum foil, which is coated with the platinum black. Just note it, this is a platinum wire which is coated with which is at the end there is a platinum foil which is coated with the platinum black, and that setup is locked or sealed in a glass envelope, and the gas envelope consisting of a small inlet, and this setup is entirely dipped in a solution containing 1 molar HCl solution or 1 molar H plus solution. എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഒരു ഗ്ലാസ് വെസൽ ഉണ്ടാവും, അതിൽ H+ അയോൺസ് ഉണ്ടാവും. ടു ദാറ്റ് സൊല്യൂഷൻ നമ്മളിപ്പോൾ ഉണ്ടാക്കി വെച്ചിരിക്കുന്ന ആ ഗ്ലാസ് എൻവലപ്പ് വിച്ച് കൺസിസ്റ്റിംഗ് ഓഫ് എ ഗ്ലാസ് ട്യൂബ്, അറ്റ് ദ എൻഡ് ദർ ഇസ് എ പ്ലാറ്റിനം ഫോയിൽ, a platinum wire, at the end there is a platinum foil which is coated with a platinum black. ഈ സെറ്റപ്പ് നമ്മൾ ഈ ഗ്ലാസ് എൻവലപ്പിനുള്ളിൽ സീൽ ചെയ്തിട്ട് നമ്മൾ ഈ പറയുന്ന ബീക്കറിലേക്ക് നമ്മൾ ഡിപ്പ് ചെയ്ത് വെക്കുന്നു. You can see there is an inlet of hydrogen. H2 gas inlet is be there. So through that inlet we are passing the hydrogen gas. Note it down. It should be the pressure of the gas to be bubbled should be 1 atm pressure. That's why standard the abbreviation is She. She means the S stands for standard. Standard means the condition should be standard. The concentration should be 1 molar and the pressure should be, what is the pressure? That is 1 atm pressure and 298 Kelvin. Okay, let us read the points. ഞാനിപ്പോൾ പറഞ്ഞതിൻ്റെ പോയിന്റ്സ് ആണ് താഴെ കൊടുത്തിരിക്കുന്നത്. A platinum foil attached to platinum wire is sealed through a glass tube and it is dipped in a solution containing hydrogen ion of 1 molar concentration at temperature of 298 Kelvin, and the hydrogen gas at 1 atm pressure, note it down, the pressure should be 1 atm, is constantly bubbled through the solution. The platinum foil is coated with the platinum black. Okay, and the hydrogen ion is in contact with the solution containing H plus ions and which function as irreversible reaction. Let us discuss the equations. If it is act as anode, the reaction will be H plus H2 gives 2H plus 2 electron. We know that this is anode is the oxidation reaction. Here the electrons are released. At a cathode, the reaction get reverted, that is 2H plus 2 electron give H2. That is the reaction. And my main important point is its EMF value is equal to 0. This is a gas ion electrode, so the cell representation can be written like this: H plus bar H2 bar PT. What is the general format of gas ion electrode? That is, the general format is PT bar x PT bar x2 bar x minus. So like here, that is if it is this is a representation of hydrogen electrode. If it is act as cathode, if it is anode, the representation is PT bar H2 bar H plus. That is either this gets reverted, because when you write the cell representation of a cathode, first of all you have to write the solution, then you have to write the ion the metal, like that you have to be written. Okay, so let us discuss the main applications of reference electrode. Reference electrode is mainly having to determine the cell potential value, and if we are dealing about the standard hydrogen electrode, let us discuss its application. The first application of She is determination of standard electrode potential of any electrode. We know the value of zinc electrode, what is minus 0.76. We know the value of copper is 0.34. How do you know that? We just coupled that is electrode with a reference electrode, and some calculations it revealed the data, or it give the results. So first of all, I am going to I'm going to show you the steps or the process for the determination of zinc electrode, electrode potential of zinc electrode using She. Before that, we need to write the setup. Two main points should be discussed. The first point is, it is impossible to know the absolute value of a single electrode potential, because neither oxidation or reduction take place independently. Hence, we find the relative electrode potential by coupling it with a reference electrode. Which means, if you take an electrode, which means a zinc rod dipped in zinc sulfate, if you connected that electrode setup to a voltmeter, we can see the reading of the voltmeter is 0. Why? That is the point. It is impossible to know the absolute value of a single electrode potential, because neither oxidation or reduction take place independently. It requires the help of another electrode. So mainly we are using reference electrode for that. Okay, second one, in order to measure the standard electrode potential of zinc electrode, the zinc electrode is dipped in 1 molar zinc sulfate solution and it is coupled with the She. Let us draw the pictorial representation or the arrangement of this. Here you can see this is a zinc, this is a beaker which consisting of 1 molar zinc sulfate solution, and there is a zinc strip or a zinc rod is dipped into this, and there is a hydrogen electrode is be here, and the setup is there is a platinum wire at the end, there is a platinum foil which is coated with a platinum black, which is called in a glassy envelope. It is dipped in a 1 molar HCl solution. For the proper maintaining the conductivity, we are mixed it with there is a platinum, there is a salt bridge is dipped here. First of all, just write the cell representation. Here zinc acts as anode, so representation can be written like this: Zn bar Zn 2 plus. Here it is 2 plus is ZnSO4. I written as this is solid and this is aqueous, and the solid, and its concentration should be 1 molar. Then there is a salt bridge is there. Write the cathode data. If it is she is a cathode, you written like this: H plus of concentration 1 molar bar, this is aqueous, and here hydrogen gas is formed bubbled, and its pressure is 1 atm pressure, and there is a platinum electrode is be there. It is a solid form to take up the potential. So when you couple these, we got this arrangement, and we can see that this is the arrangement. The reactions can be written as the anode reaction can be written like this. When you write the anode reaction, that is Zn gives Zn 2 plus plus 2 electron. If the cathode is She, the cathode reaction can be written like this: cathode reaction is 2H plus plus 2 electron giving H2. So we know that E cell is equal to E0 cell. Okay, E0 cell. Um, Sorry, E0 cell. E cell is equal to E cathode minus E anode. Here the E cathode is She, and its value can be written as 0 minus E anode is E Zn. So from the equation, E cell value can be obtained from where we can be. It is obtained from what about that? It is obtained from the voltmeter reading. So if the voltmeter reading is 0.76, we know that is 0 minus EZN. So the value of EZN is equal to, here is standard condition, we can put the 0, that is minus 0.76. This value should be known for you. From this way we can calculate the, or we can determine the concentration of that. Okay, so that's about this. Let us discuss the disadvantages of She. It is quite difficult to set up hydrogen electron. Second point is it cannot be used in solution containing redox systems, and it's also readily affected by compounds of HgAs and oxidizing agents like Fe3 plus MnO4 minus chromate, and consequently it is an electrode cannot be having used in solutions containing their ions. Thank you. Have a nice day.